Welcome to my battery capacity tutorial. I'm going to talk about amps, amp hours, watt hours, C ratings, and other important things that you need to know when working with batteries. First, I'd like to talk about a common question people have. Let's say a battery like this is capable of delivering 1 amp. Just because a battery or any power source is capable of delivering 1 amp, it doesn't mean that if you connect it to something, it will supply 1 amp. Voltage sources like batteries will only deliver as much current as the load needs. The amount that the load draws depends on the load. It could be a low resistance load that draws a lot of current, a high resistance load that draws barely any current, or it could be a complicated digital device like this microcontroller, which draws a different amount of current depending on what it's doing. This 2 amp hour battery is capable of delivering over 4 amps, but with the motor I have connected to it, it's only delivering 2 milliamps. And it can do it for hundreds of hours. If you're confused so far, keep watching. The first thing that you need to understand is that amps and amp hours are two completely different things. You've heard of amps or amperes before. That's a unit to describe how much electrical current is flowing. But what is an amp hour? An amp hour is a completely different unit. It's a measure of capacity, and it's a way to help estimate the amount of energy that a battery can hold. For example, here we have a rechargeable AA battery. The capacity is 2000 milliamp hours, or 2 amp hours. The simple explanation of what this means is that it can supply 2 amps for 1 hour until the battery runs out of energy. 2 amps multiplied by 1 hour is 2 amp hours. If we draw less current, the battery lasts longer. It could deliver 1 amp for 2 hours. And if we draw more current, the battery gets drained faster. It can deliver 4 amps for half an hour. So amp hours are a simple way of estimating battery life, and in general, capacity in amp hours divided by the load in amps gives you the battery life in hours. So, does that mean that this battery can deliver 120 amps for 1 minute? Let's try. It seems the battery is only able to supply 9 amps, and it's heating up a lot. Let's Google the datasheet of the battery and see what the limitation is. Take a look at this. This battery has an internal impedance of 25 milliohms. So it's kind of like there's a little resistor inside the battery, but in reality it's going to be a limitation of the battery's chemical reaction and electrodes. This internal impedance limits the amount of current that the battery can deliver, and from an electronics perspective, it effectively becomes the source of heat when the battery is delivering current. This explains why very few batteries can actually deliver 120 amps, and it raises the question, how much current can a battery safely deliver? A little lower in the datasheet, we can see the discharge curves of the battery, ranging from 400 milliamps to 4 amps. So it's implied that we probably shouldn't be discharging this battery at a rate higher than 4 amps. Oops. Also, take a look at this. Notice how the effective capacity changes depending on how fast we discharge the battery. This is only a 2 amp hour battery when we discharge it at under 400 milliamps. If we discharge it at 4 amps, the effective capacity is only 1.7 amp hours, because now we're losing a lot more energy in the form of internal heating. And the overall trend is that the more current we draw, the lower the output voltage will be, because we're dropping voltage across the internal resistance of the battery. So this 1.2 volt 2 amp hour rating is only a guideline of what you can expect to see under ideal conditions. Okay, that's amp hours. Now here's something to get you thinking. This is a 1.2 volt 2 amp hour battery. Over here, we have a 9.6 volt 2 amp hour battery pack. So if these are both 2 amp hour batteries, do they both hold the same amount of energy? Of course not. The 1.2 volt battery will theoretically deliver 2 amps for 1 hour, with a voltage of around 1.2 volts. The 9.6 volt battery pack will also theoretically deliver 2 amps for 1 hour, but with a voltage of around 9.6 volts. So one way we can compare the stored energy of these two batteries is to use another unit called watt hours. Volts times amps equals watts, so you can probably guess that volts times amp hours equals watt hours. The single cell has a capacity of 2.4 watt hours, and the larger battery pack has a capacity of 19.2 watt hours. Now it's more obvious which battery stores more energy, because we're comparing apples to apples and watt hours to watt hours. Now let's talk about C ratings. Here are two batteries that seem identical. They both have a nominal voltage of 11.1 volts and a capacity of 2200 milliamp hours. They look the same, but one of them has a 20C rating and the other is rated at 40C. But what is a C rating? The C rating is an informal way of describing how much current the battery can safely deliver. If you show a battery discharge curve like this to most people, they'll have no idea what it means, and it's not very exciting marketing material. So marketers like to use C ratings instead. The C refers to the battery's capacity in amp hours. So this 20C battery can deliver 20 times C, or 20 times 2.2 amp hours. So this battery can safely deliver up to 44 amps. And this 40C battery can safely deliver 88 amps. Now, are you confused? Because you should be. Remember that amps and amp hours are completely different units. C ratings are confusing because they screw up the units. You multiply the amp hour capacity by the C rating, and then you pretend the result